Alright, what's up guys? In this video we're going to pick up with some multivariable calculus, and we're going to be evaluating another triple integral here in spherical coordinates. So we're given this triple integral from 0 to 2 pi, from 0 to pi over 2, from 0 to 2 cosine phi, and then we have rho squared sine phi, d rho, d phi, d theta. So in this particular case, for this triple integral, we're going to integrate respect to rho first, treating phi and theta as a constant, integrate respect to phi, treating theta as a constant. Then last, integrate respect to theta. And much like we do for the double integrals, we'll integrate from the innermost integral here to the outermost one. And that's pretty much how it goes, and it's already set up for us, so all we got to do is evaluate it. So it's going to be from 0 to 2 cosine phi, and we got rho squared sine phi, and then we're integrating this with respect to rho. So since we're integrating respect to rho first, that means that sine phi can be factored out, or it can come in front there. We can pull it out, and that'll leave us with rho squared in our integrand, which we apply the power rule, and we'll get rho cubed over 3. And it's going to be evaluated from 0 to 2 cosine phi. So recall that 2 cubed is 8, so we would have 8 over 3. Now the cosine phi is also being cubed, so that would be cosine cubed phi, and then we would have to multiply by sine phi. Now if we stick in a 0, we're just going to get 0, so we would now get down to the double integral from 0 to 2 pi, from 0 to pi over 2, and what we'll have is 8 over 3 cosine cubed phi multiplied by sine phi d phi d theta. So we're down to the double now. So next we're integrating with respect to phi. So it's going to be from 0 to pi over 2. We'll have 8 over 3 cosine cubed phi multiplied by sine phi. And again, this is going to be integrated with respect to phi. My pen is going out here. Hold on a second. Try to see if I can get it to, there you go. Try to get it to come back open now. Okay, so let's evaluate this. So again, 8 over 3 is a constant. It can be factored out. So just pull that out. So if you pull out the 8 over 3, what you'll be left with in the integrand is from 0 to pi over 2, we'll have cosine cubed phi multiplied by sine phi integrated with respect to phi. So we can do a u substitution for this. Let's let u equal cosine phi. So that means that du is negative sine phi. Don't forget to multiply by d phi, so we'll get negative 1 over sine phi du is equal to d phi. And so what we're going to get after we do the simplification, we'll still have our 8 over 3. We'll have to change the limits, and looks like we'll just end up with negative u cubed du. So let's change the limits. So u here was cosine phi, so we'll stick in a 0 and a pi over 2. So you stick in a 0, so you stick in cosine of 0. So cosine of 0 is 1, and then cosine of pi over 2. That's going to be 0. So what I'm going to have to do in this case, because what we'll end up getting is 1 as the lower and 0 as the upper, So what I'm going to do is I'm going to flip the limits or swap them, but when I do that, I'm going to have to change the sign of the integral. So I'm going to bring the negative out front. So we'll have negative 8 over 3, and I can just flip the limits now from 0 to 1, because I did change the sign of the integral, which I'm allowed to do. That's a property of definite integrals. And then this would be negative u cubed du. So now we know that two negatives will give us a positive. Okay. So this would be 8 over 3. This would be u to the 4th over 4 from 0 to 1. So this is going to be essentially 8 over 3 times 1 over 4, which is 8 over 12. And we can reduce 8 over 12 down to 2 over 3 if we divide both the numerator and denominator by 4. Let's go to another sheet. Okay. So what we're going to end up getting is essentially 2/3. So now our last integral will be from 0 to 2 pi, and we're integrating 2 over 3 with respect to theta. So it's pretty obvious here that we're integrating a constant with respect to theta. So this would be 2 over 3 multiplied by theta, evaluated from 0 to 2 pi. So we're just going to end up getting 4 pi over 3. If we stick in a 0, we'll just get 0. So we're not taking anything away. So we'll have 4 pi over 3. And that's going to be your final answer. So your final answer for this triple integral, which was from 0 to 2 pi, from 0 to pi over 2, from 0 to 2 cosine phi, and it was rho squared sine phi d rho d phi d theta. So our answer is going to be 4 pi over 3. That's the solution. Okay, so let me know if you have any questions about it, and I'll be more than happy to talk about it with you. Alright, so that's going to be it, guys. Y'all take care. See you next time.